With increased compliance and tighter building regulations aimed at improving energy performance and reducing carbon emissions, architects and design engineers are increasingly turning to central plant and HIU-based heating systems as an efficient and cost-effective solution for multi-dwelling developments and apartments. Traditionally, communal heating and hot water systems have been structured around a shared central supply, with multiple tenants sharing energy consumption costs. The advantages of this over a system of individual domestic boilers are well understood, but the inequitable system of billing does little to promote energy-saving attitudes amongst tenants. Heat interface units act as a bridge between the central plant primary circuit and each apartment, and via built-in heat exchangers provide instantaneous heating and hot water. By introducing an inline heat meter into the design, energy consumption for each dwelling can be accurately measured, reported and charged accordingly. The Lovato Macuk E is an indirect electronic heat interface unit available in multiple configurations with output capacities of up to 89 kilowatts for domestic hot water and 33 kilowatts for heating. Operating from primary temperatures as low as 50 degrees, it is perfectly suited to multi-occupancy situations in the case of tower blocks and high-density residential areas, where communal and district heating systems are installed. The simple and compact design separates the primary heat source from the secondary heating and hot water circuits, making it easy to control and maintain with no interruption to the central plant system. Instantaneous hot water and heating are available via two internal heat exchangers. With capacities up to 33.7 litres per minute, much higher domestic hot water flow rates are available compared to traditional combi boilers, who typically achieve a maximum of 14 litres per minute. Additionally, when heating and hot water are simultaneously required, the Macuk E intelligently balances the supply of both. For DHW flow rates up to 6 litres per minute, the system continues to recognise a heating requirement, maintaining minimum room temperatures where possible. Installation of the Macuk E is quick and simple, and because of its compact size, fits inside a standard 600mm kitchen cabinet. The universal first fix bracket is plumbed into the apartment services, and because of the absence of any gas supply, no gas-safe registered engineer is required. The heat interface unit is hung from a wall-mounted bracket and, once aligned, connects to the first fix bracket via 7 couplings. To complete the installation, connect to the mains power via the terminal connection block. For a top feed supply, an optional pipework connection kit and frame spacer brackets are available. Key components of the Macuk E include a primary circuit modulating two-way valve with stepper motor for the regulation of domestic hot water temperature, a Class 2 M-bus or radio-controlled heat meter for monitoring energy use, a 2-port valve and electric actuator for the regulation of heating and return temperature control, an electronic control panel, 2 heat exchangers, one for domestic hot water and one for heating, a primary circuit Y strainer, NTC temperature sensors on the primary flow, heating and domestic hot water circuits, an electronic flow switch, a secondary heating circuit PWM circulation pump, a cold water meter, an anti-water hammer valve, a 7-litre expansion vessel and 3-bar safety valve. Step 1 in correctly commissioning the Macuk E is to charge and pressurise the system. Firstly, press the power button on the control panel. Next, press the summer, winter and power button simultaneously, and using the DHW- button, navigate to the H2O menu. Open all shut-off valves and, via the filling loop, charge the system to the desired pressure. Press the summer-winter button and the circulation pump will start to run. Lastly, use the manual air vents to bleed all pipework of excess air before closing the filling loop valve. Press the power button to exit the heating circuit pressure mode. Step 2 in commissioning the system is to set the clock. Press the heating plus and minus buttons simultaneously and using the DHW Plus button, press to select the hour value. Press the Summer/Winter button and repeat the process for the minutes value. Finally, press the power button to exit the clock setting mode. Step 3 in commissioning the system is to balance and set the system flow rate. For this example, based on a primary flow temperature of 60 degrees and a primary flow rate of 1500 litres per hour, a 40 PHE system will be configured to supply 22.9 litres per minute at 50 degrees Celsius. Firstly, via the control panel, access the stepper motor setup menu and adjust the value from the factory set 600 to 790. Next, fully open all hot water taps and allow to run. As the temperature in the primary return stabilizes, the flow rate can now be cross-referenced with instantaneous primary flow readings on the heat meter. For details how to access the parameters menu and for information on further commissioning steps, please refer to the installation manual. The Macuk E is electronically controlled for maximum comfort and efficiency. To ensure instant demand for domestic hot water, an electronically controlled hot water bypass provides a route for flow under minimum load conditions. When all radiator control valves are closed and there is no demand for hot water, the stepper motor reacts to a temperature sensor upstream of the heat exchanger and the valve opens just enough to allow minimal flow. With this balanced control and hot water continually present in the primary feed, domestic hot water of the desired temperature is always instantly available. For maximum efficiency, programmable time bands can be set via the control panel to ensure the bypass function is only available when it is needed most. Based on a primary circuit inlet temperature of 60 degrees, the following illustrates the effects of variable hot water demand on the system. To sustain stable domestic hot water temperatures under varying load conditions, the stepper motor reacts by controlling primary circuit flow rates. As the demand for hot water in the apartment increases, the stepper motor opens the valve further, increasing the flow rate and, in turn, the volume of energy to the heat exchanger. This variable control maximizes system efficiency, resulting in lower energy consumption. The heating function optimizes control by monitoring flow temperatures to the secondary heating circuit. When the heating is first switched on, the electric actuator opens the two-port valve. As the room temperature rises and stabilizes, the system senses a change in the temperature in the secondary circuit flow, and in turn, the PWM pump adjusts its speed to balance and preserve the delta T gap. This varying electronic control maintains optimum flow temperatures and saves energy by keeping the primary flow rate as low as possible. Additional system efficiency can be achieved via an option control unit that manages weather compensation curves by monitoring outside changes in temperature. When heating and domestic hot water are simultaneously required, the Macuk E intelligently balances the supply of both for DHW flow rates of up to 6 litres per minute. The following illustrates the effects on the whole system of variable domestic hot water demand when the heating is active. As the demand for hot water increases and exceeds 6 litres per minute, the electric actuator closes the two-port valve and in turn the heating circuit. As demand further increases, the stepper motor continues to regulate and adjust the modulating valve to meet the domestic hot water requirement. Saving energy is one of the central issues of our time, and encouraging homeowners and tenants of multi-dwelling properties to be more energy conscious has become a priority for many governing authorities. Designed with efficiency in mind, the Macuk E is fitted with a heat meter for the physical accurate recording of energy consumption. Either by M-bus or radio, operating data is sent to a communication unit where it can be remotely accessed and monitored for the purpose of billing. In conjunction with smart meter technology, landlords can offer a more transparent service where tenants are not only exposed to energy consumption information, but only pay for the energy they actually use. Furthermore, the system can be integrated with a variety of smart pay services offering landlords different billing options. By choosing between monthly billing, auto top-up and prepayment options, risk can be managed by mitigating the potential for bad debt. Compliant with all government and EU energy efficiency directives, the Lovato Macuk E is independently tested by RAS, Kiwa, BESRA, BISA and is CE marked. Benefits include easy and efficient integration of renewable energy products such as CHP, biomass and heat pumps. Lower primary temperatures, reducing operating costs, carbon emissions and our dependence on fossil fuels. Around-the-clock remote monitoring of system information via wireless internet connectivity, providing 100% control and fewer unnecessary service call-outs. Unparalleled high hot water production from super low primary flow temperatures. Fully insulated, elegant and simple design with future-proof first fix bracket, making HIU replacement possible with no adjustment to pipework. Fully adjustable bypass, ensuring domestic hot water is instantly available and with programmable control strikes the perfect balance between comfort and efficiency. Fully settable secondary heating return temperature for maximum control and system efficiency. Accurate metering of energy consumption for a fairer system of billing. Support for smart pay technology and monthly and prepayment plan options. With increased housing demand and tighter building regulations focused on energy efficiency, the building industry is experiencing a shift towards contracting for performance. Heat interface units are now commonly used in new developments to help achieve zero carbon ratings, and developers are encouraged to recognize the through-life sustainability of products as part of their procurement process. The Lovato Macuk E has been developed with this in mind, and its low embodied carbon footprint make it an innovative and leading product in this category. For performance test results, technical information, or a consultation of how the Lovato Macuk E can integrate with your central plant system, please contact us.